Greetings students. In this lecture, we'll talk about the symmetry of a function. Now we can check the symmetry of a function about x-axis, y-axis and origin. To check the symmetry about y-axis, we have to replace xy by minus xy in the equation, and if there is no change, then this means that the given function is symmetric about y-axis. Now if we replace xy by x minus y in the equation and then no change occurs, then this means that it is symmetric about x-axis, while if we replace xy by minus x minus y in the equation and no change occurs, then it is symmetric by origin. So this means that a function can be symmetric about x-axis, y-axis and origin. To check about y-axis, we have to replace x by minus x. To check symmetric about x-axis, we have to replace y by minus y. And to check the symmetry about origin, we have to replace both x, y by minus x minus y. And in all three cases, if we get the same answer, we say that they are symmetric about their specific axis or origin. Let us try to understand it with the help of few examples. Let's check whether this function is symmetric about x-axis, y-axis or origin. Now we know for x-axis we have to replace y by minus y. So we'll replace y by minus y, 3x cube minus x. Y is equal to minus 3x cube minus x. Do we get the answer same as this one? Of course not. So we'd say that it is not symmetric about x-axis. Moving on to the y-axis, we have to replace x by minus x. So y remains the same, minus 3x cube plus x. Now we take minus common and we see that we do not get the same answer as minus is common. So we say that this is also not symmetric about y-axis. Now moving on to the origin. Now for origin, we know that we have to replace both x and y by minus x and minus y. So by doing it, we would have minus 3x cube plus x, taking minus common, 3x cube minus x. Minus cancels out with minus and we have 3x cube minus x, which matches with our question. So we say that this is symmetric about origin but not about y-axis and x-axis. Now moving on to the next question that says x square minus 2y square is equal to 3. Now let's check that this is symmetric about x-axis. For x-axis, we replace y by minus y. By doing it, as it is a square, so we'll have the same answer. Hence we say that it is symmetric about x-axis. Now y-axis, replacing x by minus x, we'll have the same answer. 2y square is equal to 3. This means that it is also symmetric about the y-axis. Now origin, x square, y square, and we'll get the same answer. So we say that it is also symmetric about origin. So this specific function is symmetric about x-axis, y-axis and origin. Now in these two examples, we see that we replaced y with minus y here, but due to square it remains the same, and in this one we replaced x by minus x, but due to the square it remains the same, and in the origin we replaced minus x and minus y, and we got the same answer because we have squares. So hence our function is symmetric about x-axis, y-axis and origin. Well, I hope you got the concept, and that sums up our topic.